this session, the next topic, namely definite integrals. Suppose you are asked to find the integral of x square dx. What will be your answer? X cubed by 3 plus c. What is that c? A constant. Okay, what is that constant? What is the value of that constant? It's not known. That is why this answer is not definite. And we call this integral indefinite integral. On the other hand, we will be going to get acquainted with a new type of integral, namely integral a to b f of x dx. Look at the symbolism. Integral a to b f of x dx. Here a is called lower limit of this definite integral, b is called the upper limit of this definite integral. By the by, what is the definition for this? How can you get this? This is nothing but f of b minus f of a, where capital F of x is nothing but integral a to b f of x dx. That is, if the indefinite integral f of x dx is equal to capital F of x, then the definite integral a to b f of x dx is defined to be f of b minus f of a. My dear friends, it is not the definition actually. It is a famous theorem called, standard theorem called fundamental theorem of integral calculus. It is the essence of a theorem. Of course, we shall be making use of that as a result or as a formula, and the definite integrals hereafter, all the numerical problems and the theoretical considerations will be based on this result. For the present, we consider this as a formula. Okay. As an example, suppose integral x square dx 0 to 1 is asking. What can you have? Without the limits, what is the indefinite integral? Integral of x square is x cubed by 3, isn't it? It is x cubed by 3 plus c between the limit 0 to 1. Upper limit is 1, lower limit is 0. This is capital F of x. And as per our discussion which we could have just done, f of b minus f of a is the answer. That is 1 cubed by 3 plus c. 0 cubed by 3 plus c. C and c will be cancelled, so that the answer is 1 by 3. Basing on this experience, hereafter, while calculating the indefinite integral, we just forget this c. We do not use that c, because automatically it will be cancelled, isn't it? Automatically it will be cancelled. Therefore, integral 0 to 1 of x square dx is 1 by 3. Another example. By looking at another example, after looking at another example, we shall go to the theoretical part, or rather the standard results and formulae in this chapter. Well, integral 2x plus 3 dx between the limits 1 to 2. What is it? What is the integral of 2x? X square. What is the integral of 3? 3x. Do you need plus c? Of course, if you are interested to have the indefinite integral, we put c, but we are not interested here, isn't it? Between the limits 1 and 2. First of all, upper limit is going to be substituted. It becomes 2 square plus 3 into 2 minus, then the turn comes to the lower limit, 1 square plus 3 into 1. 2 square is 4, 3 is 6, 6 plus 4 is 10, that is 10 minus 1 plus 3 is 4, so it is 6. Like that we calculate the definite integrals which are asked. Now let us go through the theoretical part, rather important formulas and results in this chapter. Important formulas and standard results. Very first one, suppose we are calculating integral a to b f of x dx. If the situation demands, if the necessity demands, if it is needed for you to have to interchange the limits a to b or b to a, it can also be done by taking minus integral b to a f of x dx. That is the very first one, and it can easily be proved very easily. Look here, proof. If you want to have the proof, if integral f of x dx is equal to capital F of x plus c, then LHS is equal to f of b minus f of a. You get minus a common factor. It can be taken as f of a minus f of b, so that it is nothing but RHS. It's nothing but RHS. What is f of a minus f of b? The integral, the definite integral which is present in the right hand side is just nothing but this. Therefore, LHS is equal to RHS. You see, every time we do not take part in proving the so-called result, as it looks very simple, we have just touched it. Well, this is the first result. Next, second result. Integral a to c f of x dx is equal to integral a to b f of x dx plus integral b to c f of x dx. This is a very useful result. Very useful result, according to which one particular integral can be split into 2 or 3 or more number of integrals as you require. What I mean to say is, this can again be written as integral a to c f of x dx is equal to integral like this also. Integral a to b1 f of x dx plus integral b1 to b2 f of x dx plus integral b2 to b3 f of x dx and so on, integral bn to c f of x dx. Of course, this condition must be satisfied. A less than b1 less than b2 less than b3 less than etc less than bn less than c. At these places we can take rest. What I mean to say is, up to b1 integral, up to b2, up to b3, like that, stepwise integration. And this particular format, this particular formula is very useful for us when the function, the consideration of the function at crucial intervals is to be considered. As an example, let me consider the integral 0 to 2 modulus of 1 minus x. Between 0 and 2, mod 1 minus x has different phases. You know, you see 0, 1, x. Between 0 and 1, suppose x lies here, x is less than 1. So the distance between them is 1 minus x. So no problem, it is 0 to 1, 1 minus x dx. Plus between 1 and 2, if x lies here, 1 is greater than x, distance between 1 and x can be taken as x minus 1, so it is integral 1 to 2x minus 1 dx, isn't it? Integral x 1 to 2 x minus 1 dx. So to find the integral 1 to 2 mod 1 minus x dx exactly and accurately without any mistake, you have to split that at x is equal to 1. Why? Because to the left of 1 and to the right of 1, the behavior of the function mod 1 minus x is different. In order to integrate it, you must concentrate on those two intervals separately and individually, so that the function can be estimated in that particular interval. Therefore, this particular property is very much useful in considering such integrals. Yes, this is the so-called second property. One more property is also there, that is the third property. Let me illustrate this property first. Then later on I shall give the statement of this property. Look here, what is integral 1 to 2 x square dx? You need not have any steps. You can directly mention the answer. For x square, what is the indefinite integral? X cubed by 3 between 1 and 2. 2 cubed by 3 minus 1 cubed by 3, isn't it? It is x cubed between the limits 1 to 2. It is therefore 2 cubed by 3 minus 1 cubed by 3. Hence it is 8 minus 1 by 3. It is 7 by 3. Now I am asking another question. X square, y square dy. Come on, what is the answer? 7 by 3. Integral 1 to 2 theta square d theta. Same answer. Integral 1 to 2 r square dr. Same answer. What is happening here? How can you generalize this result? You have not changed the function. You have not changed the limits. Everything is absolutely similar. You have just changed the variable only, the name of the variable only. In such a case, this definite integral, this one, all of them are equal. That we are now going to generalize. That is, the third property is integral a to b f of x dx is equal to integral a to b f of r dr is equal to integral a to b f of t dt is equal to integral a to b f of theta d theta is equal to etc. 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 That can be visualized, of course, by means of a very simple example like this. As an example only, for the sake of an example only, I have created this problem. Not only this, for any problem, for any integral, definite integral, you can observe the same. This is a beautiful property and this is very much useful in theoretical considerations. Yes. The next property, I have put a star mark before that. What I mean to say is, it is one of the most important formulas. It is important because it is widely in use. It has as many applications as you look at. Such a famous formula it is. What is that? What is that? Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. F of a minus x dx. Yes. How is it useful? What type of typical situations are saved by using this formula? You observe this function, integral 0 to pi by 2 sine cube x by sine cube x plus cos cube x. Suppose a function is there. You see, if these limits are not given, sine cube x by sine cube plus cos cube x is not an easy problem for indefinite integration. It's not easy. Of course, it is not impossible to get it. It's not so easy. But as the limits are given, we are manipulating it. We are getting it. You please observe. You take in the place of x, we can substitute upper limit minus x. Here, upper limit minus x is pi by 2 minus x. What is that? Pi by 2 minus x. What is sine pi by 2 minus x? Cos x. Integral 0 to pi by 2 cos cube x by sine pi by 2 minus x is cos cube x cos pi by 2 minus x sine cube x dx. Let's say if you name this integral I, what is I plus I? You just add I plus I. What is going to happen? This plus this In these two are having same denominator. Of course, what is the denominator? Sin cube x plus cos cube x. And what do you say about the numerators? Sin cube x plus cos cube x. Sin cube x plus cos cube x, the same quantity is obtained both in the numerator and denominator. So it is 1. Integral of 1 is x. So it is x between the limits 0 to pi by 2. Hence it is nothing but pi by 2 minus 0 or pi by 2. But what is I plus I? 2i. Therefore 2i is equal to pi by 2. Hence I is equal to pi by 4. Pi by 4. Like this formula helps us a lot. Let us observe some more applications of this formula. Integral 0 to a f of x by f of x plus f of a minus x. Suppose you have such thing. What do you have? You apply, let me call this I. Now you replace. In the place of x, a minus x. What happens? This is integral 0 to a f of a minus x by f of a minus x plus a minus of a minus x is just nothing but f of x dx. As in the previous case, you add these two again. What is I plus I? Integral 0 to a. These two are having the same denominator. And if you add these two, what are you going to get? F of x plus f of a minus x. If you cancel them again, 1 in the integrand part. So it is x between the limit 0 to a. That is a minus 0 or simply a. I plus I is a. Therefore, I is equal to a by 2. I is equal to a by 2. Hence, we will be making use of this step as a standard formula. Standard formula. The proof of this formula is very clear and visible on the board. You can agree with that. Yes. Okay, which are all the different applications, rather uses of this formula? Answer it. Integral 0 to 5 root x by root x plus root 5 minus x. As this is the problem in definite integrals, we just read the answer as 5 by 2. Otherwise, it will be a tedious job. Of course, not very difficult, but not so easy in the indefinite integration. Come on, f of x is root x. F of a minus x is root 5 minus x. According to that result, the answer is 5 by 2. Answer is 5 by 2. Again, integral 0 to 1 x to the power of 5 by 2 by x to the power of 5 by 2 plus 1 minus x whole to the power of 5 by 2 dx. You will look at the problem, how bulkier it is, if at all it is not given with the limits. Even then, that problem can be solved on this part itself within 5 seconds. What is the answer? In the place of a, what are you having? A is 1. Of course, f of x is x power 5 by 2. F of a minus x is 1 minus x whole power 5 by 2. And the denominator looks like f of x plus f of a minus x, isn't it? Hence, the answer is 1 by 2. Direct answer is 1 by 2. Well done, well done, well done. Just like that, integral 0 to pi by 2 f of sin x by f of sin x plus f of cos x dx is equal to. Come on, friend, you must be able to tell me the answer quickly on this part. What is the answer? Come on, guess. It is pi by 4. Why? Because this is f of x. Under the place of a, we have pi by 2. And you replace x by a minus x, that is pi by 2 minus x. This is f of sin x plus f of sin pi by 2 minus x. So this takes this form only, f of x by f of x plus f of a minus x. Again the answer is a by 2, and in the place of a we have pi by 2. So pi by 2 is nothing but pi by 4. Pi by 4. Well done. Integral 0 to pi by 2 sin power 5x by sin power 5x plus cos power 5x. What will be the answer? Come on. Again, f of x is sin power 5x and f of pi by 2 minus x is cos power 5x. Again, it satisfies the condition. Again, here answer is pi by 2 by 2. Answer is pi by 4. It is pi by 4. Like that, you can have so many applications. You see, here we could have had sin x and cos x only. It is just not necessary. It might be given in terms of tan x and cot x also. There also you will be able to apply this result. Let us see some more examples. Observe this. Integral of 0 to pi by 2 root tan x by root tan x plus root cos x. F of x is this root tan x. F of a minus x, that is f of pi by 2 minus x, is root of tan pi by 2 minus x, that is root cot x. Again, it could take the same shape. Again, the answer is a by 2, hence the answer is pi by 4. Answer is pi by 4, like that. So, such a great utility it exhibits, such a great benefit it offers. That is why that formula has become very important. Of course, the basic of this result is nothing but integral 0 to a f of x dx is therefore equal to integral 0 to a f of a minus x. Basing on this only, we could have got this result, isn't it? This is the basic part. Basing on this only, we could have arrived at that. Okay. Next one. The next result we have is when compared to the previous result, this is also equally important, equally useful. As at so many occasions we use this format also. Yes, what does it say? A plus b minus x. Previously, upper limit minus x. But here, lower limit plus upper limit minus x. Actually, this is formulated in the beginning. You see, if you change this, a as 0 and b as a plus b minus x is nothing but 0 plus a minus x is nothing but that. So, let us not forget this basic formula. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x. That is, of course, you please observe this. Integral 2 to 3 root x dx by root x plus root 5 minus x. What can you simplify? How can you simplify? Okay, in the place of x, by using this formula, what can you do? This is equal to integral 2 to 3 a plus b minus x. What is that? 5 minus x. In the place of x, we can write 5 minus x. In the place of x, we can write 5 minus x. 5 minus x. And in the place of x, we can write 5 minus x. Call this I. I plus I. Again, you add these two. Denominator root x plus root 5 minus 6, that is the same denominator. Think of the numerator root x plus root 5 minus 6. These two will again be cancelled. One only will be remained there. Integral of 1 dx is x between the limits 2 to 3. That is 3 minus 2 is 1. 2i is 1, hence I is 1 by 2. I is 1 by 2. My question is it necessary to use all these steps? No, not necessary. As in the previous case, we could have had integral 0 to a f of x plus f of a minus x by f of x by f of x plus f of a minus x as a by 2. You would have got the result, you know. Just like that, we can construct another useful formula. For that formula, this is a basis. Integral a to b f of x dx is equal to integral a to b f of x by f of x plus f of a plus b minus x dx is equal to integral a to b f of a plus b minus x by f of x plus f of a plus b minus x dx is equal to b minus a by 2. Beautiful formula. Observe the previous problem. Integral 0 to integral 2 to 3, it seems. Integral 2 to 3 root x by root x plus root 5 minus x dx is b minus a by 2. That is 3 minus 2, that is 1, 1 by 2. Yes, you can read the answer without having any steps. Okay, let me try. Let me give you one more question. Integral 1 to 3 x to the power of 5 by 2 by x to the power of 5 by 2 plus 4 minus x whole to the power of 5 by 2 dx. Come on, what is the answer? This is f of x, f of x, f of a plus b minus x. 1 plus 3 minus x. What is 1 plus 3? 4. 4 minus x. What is that? What is the answer for that? B minus a by 2, that is 3 minus 1 by 2. It is answer is 2 by 2 is 1. We could have made use of this formula. Yes, such a beautiful formula it is. Let us have one more such example. Integral pi by 6 to pi by 3 square root of sine power 5x by square root of sine power 5x plus square root of cos power 5x dx is equal to. My dear friend, if the problem is integral 0 to pi by 2, we might have got the answer directly as pi by 4, isn't it? But the question is not integral 0 to pi by 2. The question is pi by 6 to pi by 3. Can you use the formula a by 2 here? No. Look here. What is a? Pi by 6. What is b? Pi by 3. A plus b? Pi by 6 plus pi by 3 is nothing but pi by 2. Pi by 2 minus x. Sine power of pi by 2 minus x is cos power 5 by 2. Cos power 5x. Yes, absolutely we can use the formula b minus a by 2, that is pi by 3 minus pi by 6 by 2. What is pi by 3 minus pi by 6? It is nothing but pi by 6. 5 by 6 by 2, hence the answer is pi by 12. Please observe the change in the two problems. If the same problem, if it were asked like this, integral 0 to pi by 2, square root of sine power 5x by square root of sine power 5x plus cos power 5x. It is pi by 4. What is the base for this problem? What is the basic formula that can be used? What is the basic strategy that you may have to play in making an attack on the problem? This problem, integral 0 to a f of x by f of x plus f of a minus x is a by 2. That is pi by 2 by 2, pi by 4. But it is not such in this case. What is the formula that can be used, that must be used here? Integral a to b f of x by f of x plus f of a plus b minus x is b minus a by 2. That is pi by 3 minus pi by 6 by 2. What is pi by 3 minus pi by 6 actually? It is pi by 6. Pi by 6 by 2 is nothing but pi by 12. So you please be very careful. So many students at random, if you look at this, oh, this answer, this is a standard answer, it is pi by 4, put it like that in a half-hearted way. Some students used to have the answer as pi by 4. Please take care of the result. Please take care of the limits here. If the limits are 0 to pi by 2, the answer is pi by 4. If the limits are pi by 6 to pi by 3, the answer is pi by 12. Please be careful in observing this. So, out of these two, the formulas which are under use are different. That is why answers are different. Okay. Another important formula is now coming to us. Let us observe that very carefully. Integral minus a to a f of x dx is equal to integral minus a to a f of x dx is equal to 0 if f is an odd function. And 2 into integral 0 to a f of x dx, f of x dx, if f is an even function. And there is no importance if it is, the function is neither even nor odd. You may have to split it as minus a to 0 and 0 to a, have two separate integrals, of course. It has no importance, significance. But if f is an odd function, it is 0. If f is an even function, it is 2 into integral 0 to f of x dx. And in general, you can have like this. This is equal to integral 0 to a f of x plus f of minus x dx in general. Suppose f of x is an odd function. F of minus x becomes minus f of x. F of x minus f of x becomes 0. This stands correct. This stands true. Suppose f is an even function. Then f of minus x is f of x. F of x plus f of x is 2 into f of x. Hence the answer will be 2 into integral 0 to f of x dx. As a result, it has no importance at all. It has no importance. Okay. This is of great importance. At so many circumstances, we shall be making use of this result and getting the answer immediately. As an example, you consider this one. Integral minus 1 to 1 x square plus 1 whole to the power of 5 by 2 into 1 minus x to the power of whole power 6 by cos cube x into x cos cube x into sin square x dx. Observe this problem, how bulkier it is. If the limits are not given, can you directly solve this indefinite integral immediately? It's not so easy. I don't say that it is impossible, but it is not so easy. You see, -1 to 1 is given. Even function, even power suffix. Even function, even power suffix. Sin square x, even function. Cos cube x, even function. Because cos x is basically an even function. X, odd function. So entirely is an odd function. Hence the answer is 0. Hence the answer is 0. Like that we will be having the answer immediately. As next one. Integral minus pi to pi sin cube x by sin cube x plus cos cube x. What will be the answer? Come on. What will be the answer? First of all, is this function even function or odd function? Odd function. Odd function plus even function, you cannot decide. So, for this one, it is not useful. That function is neither even nor odd. So that it can be split as f of x plus f of minus x. Like that you can split two integrals. You cannot tell the answer directly here. You see, if I give you the problem sin power 4x by sin power 4x plus cos power 4x. What do you say about this answer? Even function, even function, even function. Total it is an even function. Hence it can be taken as 2 into integral 0 to pi by 2 sin power 4x by sin power 4x plus cos power 4x. Well done. This looks like the form f of x by f of x plus f of a minus x, pi by 2 minus 6. Hence, this part, for this part, the answer is a by 2, that is pi by 2 by 2, that is 2 into pi by 4. So, it is pi by 2. Answer is pi by 2. So, this formula makes sense, or this formula becomes useful when and only when the integrand is either even or odd. The application yields very good result and quick results. That is why answer for this question is pi by 2. Let us have one more answer for this. Answer please. Without having any steps, without using any steps, you can read the answer. This is an even function. This is an odd function. Quotient is an odd function. And it is in the form minus a to a. Hence it is surely 0. It is surely 0. Well, to use this formula, it is necessary for us to recollect, or rather to collect some odd functions and even functions. You see, you observe, suppose if I write f of x is equal to log of 1 plus x by 1 minus x. Is it even or odd? Is it even or odd? Let us see. F of minus x is equal to, what is this? Log of 1 minus x by 1 plus x. It is nothing but log of 1 plus x by 1 minus x whole to the power of minus 1. It is again minus of log of 1 plus x by 1 minus x. Hence it is nothing but minus f of x. As you are able to trace that f of minus x is equal to minus f of x, what is your opinion? It is surely an odd function. Therefore, integral minus 1 to 1 log of 1 plus x by 1 minus x. Come on friend, what is the answer? Is 0. Is 0 because it is an odd function. If it is given like that, so not only knowing the formula, you must be able to notice the nature of the given function. Nature of the given function also. Look here, integral minus 2 to 2 e power x plus e power minus x by e power x minus e power minus x dx. What will be the answer? Well, friend, let me take f of x is equal to e power x. This looks like f of x plus f of minus x, even. This looks like f of x minus f of minus x, odd. Numerator is an even function, denominator is an odd function, total quotient is an odd function, isn't it? As this is an odd function, the answer is 0. Answer is 0, as like this. At times, you may not be recognizing the nature of the function. It may look like f of x plus f of minus x, or f of x plus minus f of minus x. You must be able to trace it. If you have a function of the form f of x plus f of minus x, then you believe that it is an even function. Or otherwise, if f of x minus f of minus x, if that format is being observed, then we notice that that particular function is an odd function, as of course. What will be the answer for this? So many problems. If the limits are not given, it might be very tedious. It might be a tedious job to have the indefinite integral. You see, here you are not supposed to have the indefinite integral, as the limits are given minus pi by 2 to pi by 2. Cos x is an even function. Root of 1 minus x power 8 is again an even function. X, it's an odd function. So altogether this completely an odd function. Hence the answer is 0. Answer is 0. Like that. Next, one more result. Integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx if f of 2a minus x is equal to f of x. This is equal to 0 if f of 2a minus x is equal to minus f of x. In some crucial cases, this formula is very much in use. You observe the nature of that formation. Integral 0 to 2a f of x dx, he has asked. Okay, whatever it might be, upper limit, you call it 2a upper limit. You first find f of upper limit minus x. If you could observe that there is no change at all, you can pull 2 out. 2 into integral 0 to a. If you observe a change such that f of upper limit minus x is equal to minus f of x, then you put the answer to be 0. Answer to be 0. Let us consider two such examples. Look here. Observe this problem. Integral 0 to 2 pi sin cube x by sin power 6x plus cos power 6x dx. Upper limit is 2 pi. Sin of 2 pi minus x is 2 pi minus x means it belongs to the fourth quadrant. Cube x is negative. minus sine cube x. But this is positive, this is positive. So total, if you consider this to be f of x, then f of 2 pi minus x is minus f of x. Mercilessly you put 0. You just take it as 0. Why? Because f of x is equal to f of 2 pi minus x, isn't it? You need not calculate it at all. You need not calculate it at all. Suppose you have sine power 8x by sine power 8x plus cos power 8x. Observe this problem. Come on, friend. Let me apply this formula. 2 pi minus x. Sine of 2 pi minus x is minus sine x because it lies in the fourth quadrant. But of course, whole power 8 is given. Hence, it is sine power 8x. No change here. No change here. So, though there is no change in the function. So, what should be done? As there is no change, there is f of 2a minus x is equal to f of x. We are supposed to get 2 out. Integral 0 to pi sine power 8x by sine power 8x plus cos power 8x. Again, you apply the same technique. This is the upper limit pi, upper limit minus x. Is there any change or not? You tell me. Sine pi minus x is sine x power 8 is again sine power 8x. This is sine power 8x, that is cos power 8. Actually speaking, cos of pi minus x is minus cos x. Even though it is minus cos x, whole to the power of 8 is there. So here also we are able to observe no change at all. Hence you can get another 2, one more 2 out. So this is already this 2 is present. From this pi I am getting another 2. Integral 0 to pi by 2 sine power 8x by sine power 8x plus cos power 8x. Excellent. That has been thrown into the standard form. What is the standard form? Integral 0 to a f of x by f of x plus f of a minus x, isn't it? In the place of x, you take pi by 2 minus x. What happens? Same thing happens. This is f of x, this is f of a minus x. Hence, the answer is pi by 4. 2 2s are 4, pi by 2, pi 2. What will be the answer for this? It is pi. Likewise, you are supposed to get it simplified. Like that we get the answer. And this is the utility of this theorem. This is the utility of the theorem. Let me have one more such problem. Integral 0 to 2 pi, integral 0 to 2 pi cos cube x by sin cube x plus tan cube x. Come on, friend. What will be the answer for this? What will be the answer for this? How can you get it? Well, upper limit minus x, that is 2a minus x. Cos of 2a minus x is cos of 2 pi minus x, that is in the fourth quadrant. In the fourth quadrant it is positive, so cube, again it is positive, numerator is positive. Sine of 2 pi minus x is minus sine x, cube is there, so it is minus sine cube x and minus tan cube x, hence it will be becoming minus f of x, hence the answer is 0. Hence the answer is 0. This is simply because if you name this as f of x and if you consider f of 2 pi minus x, that is f of 2a minus x, then it is minus f of x. So that the answer is 0. So such a great utility and such great benefit it exhibits. Yes, this is the importance of this formula. Another formula. Integral 0 to pi by 2 sine power nx dx, if you name it some in. If this is in, what do you mean by I5? Integral sine power 5x dx. I6, integral sine power 6x dx. See, if this is f of x, what is f of a minus x? Cos power nx. Hence, this is again 0 to pi by 2 cos power nx dx. This can be simplified as n minus 1 by n into decrease 2 successively both from numerator and denominator, n minus 3 by n minus 2, n minus 5 by n minus 4, n minus 7 by n minus 6, and so on. Surely, absolutely, there must be an end because n is finite. You are decreasing 2 successively. If n is even, n minus 2, n minus 4, n minus 6, denominator will be 0, isn't it? No, I0 if n is even. That is equal to n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into n minus 7 by n minus 6 into etc. 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 I1 if n is odd. Now it is our responsibility to say what is I0, what is I1. What is I0? I0 is equal to integral 0 to pi by 2 sin power 0x is 1, dx is nothing but pi by 2. Therefore, where I0 is pi by 2. Okay, and I1, what is I1? I1 is integral 0 to pi by 2 sin power 1x is sin x. What is integral of sin x? Minus cos x between the limit 0 to pi by 2. Cos pi by 2 minus cos 0. So 0 minus 1 is 1, where I1 is 1. Beautiful formula. Excellent formula. This is of course called Wallis formula. W-A-L-L-I, famous mathematician, is called Wallis formula. Okay, let us now observe the applications of this formula. How can they be used? No doubt this is an excellent formula. I like to show the importance by means of a star mark beside that. You believe that it is important and useful provided you look at some numerical examples which we are now going to do.